Well, welcome back. So the last lesson was a lot, really. There are a lot of modules, a lot of component parts to it. It's all about how do we work with data frames, i.e., and I'm back at this point, I'm just going to call them tibbles again. How do we work with tibbles in R? And we're giving a good comparison of how we would subset and interact with objects in the base R syntax versus how do we subset and interact with these Tibble objects in the tidyverse syntax. And I gave an impassioned plea to you that if you had learned R in the past, take this opportunity to update your skills and learn some of the more modern data pipeline techniques with the tidyverse. And that was, yeah, so we went through a lot of material. We talked about working with the rows of a Tibble, with the filter and the arrange function. Also, the join functions work on rows. The join functions actually work on rows and add columns. And then we talked about the functions that work on columns. So we've got select and mutate, and then group by and summarize sort of like help you drill down to particular areas within your giant data set to look at subgroups and analysis within particular characteristics of the data. So one of the things that we have not talked, we mentioned it so far, and in passing, is that sometimes you need to deal with strings. Sometimes you've got actually in health data, my goodness, a lot of times you have information in the columns of your data that's string information, character strings. And we've seen some examples. We saw an example of using character matching to select particular column names out of a data set. We saw examples before where we might use a factor to make sure that people choose the correct string from a list, so that they don't type Florida with a capital F and a capital L and then lowercase everything else, because that wouldn't match because R is case sensitive. So the string lesson, we've kind of been building up to this to say, okay, well, we really do need to work with strings in R. How do we do this? This is one of the newer lessons that I've added to this material. So some of these lessons that are included in this material, I wrote 5 or 6 years ago or more. Yeah, honestly, maybe even more than 6 years ago. And they've grown and morphed and been updated over time. This is one of the newer lessons, and I think we just worked on it maybe 2 years ago or so, and have been editing it and working through this material. So this one, if there's stuff that doesn't make sense in this lesson, please send me an email. Or as I mentioned before, if you have feedback, you can go to GitHub and you can put in an issue and say, hey, there's something over here in this lesson that doesn't make sense. So feel free to give feedback, particularly, I mean, obviously give feedback on all of the lessons, because we want this material to grow and to be helpful to all of you as students. But particularly this lesson, it's one of the younger lessons. So if there's stuff that doesn't make sense, reach out and let us know. Okay, so getting in, this is what we're going to talk about today. We're going to talk about how do we match strings, how do we change and modify strings, how do we pull individual pieces out of strings, and then also how do we like chop off parts of strings and pad strings to particular widths. These techniques can all be useful in certain areas. It's a lot of times though that there's some projects that I'll need some very basic string manipulation, and then other projects I basically have to bring everything, just all of the weapons out to try to work with the data sets. So it depends on the kind of data that you have. Sometimes you'll have to do a lot of work in strings. Other times, very little. So just be that as let that kind of sit in the back of your head. Okay, so let's yeah, we're going to talk about the stringr package. The stringr package here is one of the packages in the tidyverse. If you can't memorize all of the stringr functions because I certainly haven't. The cool thing is they all start with str underscore. So you can just start typing str underscore, and then RStudio will populate, give you a predictive text like, hey, which of the stringr functions do you think that you need here? So just remember that if you get stuck, you can do $str underscore, and then something will pop up and you say, yeah, let's read about the help file for that one. Let's find out what that function is doing. Because there are a lot of stringr functions and they all do very different things. So the example data sets that we're going to use, there are two small objects. There's the fruit object. This is just a simple character vector from the stringr package. There's the sentences object. This one's a much longer character vector. It's got 720 of what are called the Harvard sentences. And then there's a complex data set from a package called ctnote. And this is something that we wrote, yeah, back in 2022, but finally got it published in 2023. This academic publishing takes forever. So this data set I'm giving you, I'll give you what we care about. There's a column called use pattern UDS. I recommend that you go read or at least skim this paper. It's not a complex paper. I think that all of the students should be able to understand it, should be accessible. So take some time and go read that paper just so that you can get the background of this data set. And right here, so we need you to install the ctnote package. You know how to install packages already. And we're going to load the ctnote package. We're going to load the tidyverse package. And then we get the data set here. So give us the outcomes from the CT. So this is a clinical trials network. This is one of the projects in the clinical trials network for the National Institute of Drug Abuse that I work on. And we'll get this data. So here are some examples, or I'm sorry, some exercises. So I'll go ahead and pause here and let you work on these. Okay, so you've had a few minutes to work on the exercises. Again, as with all of the exercises in this class, I want you to work on them in teams or with partners so that you can see different approaches to solving the same problems. And you can talk to people when you get stuck. It's very, very helpful for you. Okay, so let's talk about string matching, and then we'll wrap up this video and pick back up in the next one. So there's two functions that we care about here. So there's string detect and string count. So string detect, or str underscore detect, is to detect the presence or absence, you can reverse it, of a matching pattern. And then count is going to say how many times does this pattern show up in the string. So let's take, for example, the fruit vector, and we want to see, well, how often does the word berry or berries show up? So here's one option. We can say, let's figure out how often. So string detect, let's create a logical vector to indicate which strings have match BERR, because this is like the character intersection. You can see that the first 4 letters of berry and the first 4 letters of berries are the same character string. So this is a character intersection. And then this gives us an atomic logical vector. And then from there, we can subset the fruit vector by this logical vector, and we find all of the different berries in the data set. If we wanted to, if for whatever reason it would be difficult to find a character intersection because they're not the same like root words, you can use the or symbol and say, okay, give me everything that matches berry, or give me everything that matches the word berries. Okay. And so this is, we get the exact same answer here. What is interesting, though, is this is only matching on the strings, the string names itself. It's not matching on the classification of the fruit. So some of you who know things about the classification of fruits, you know that strawberry is not an actual berry, and banana is a berry. So strawberry, not an actual berry, is in this list. Banana, which is a berry, is not in this list. So this is matching. It's not a scientific matching. It's not that the stringr function just magically understands taxonomic classification of fruits and vegetables. It is literally matching on just the character string that was typed. And I'm going to take a pause here and just use this to reinforce the idea of that I may have mentioned this in the class before, but something called garbage in, garbage out. So if the data that you are collecting comes into your data set, comes into your database is bad, no amount of analysis is going to take bad data and turn it into good results. Okay. So just be aware of that you are going to be limited by the quality of the data that are collected. Now, you can do a lot of data cleaning, you can do a lot of data wrangling to try to help work out missings and help fix things that are misclassified or mislabeled. But again, you should be doing that with the subject matter expert, and you should do it in code so that there is a record, an audit trail of all of the changes that were made to the data. But just be aware that if you can spend time up front making sure that the data that you collect is good, then you have to spend just less time on the back end fixing problems. All right, now counting matches. So, oh, here's an exercise. Go ahead and find, so we talked about we talked about well, anyway, there's an example for berries. Go ahead and find all the fruits that have the string fruit in it. So you can work on that on your own time. Now for counting matches, this is we're going to go to the use pattern UDS column. So notice I'm in the dataset outcome DF. Did I create this? Data outcomes CT94. I may not have created this. I'll have to update this. I'll have to update this code to make sure. I'll have to update this lesson to make sure that you have outcome DF. But what you're going to do is you're going to select the column called use pattern UDS out of that, and then just take the first 20 so that we can see it on the screen. And then I want to count how many times I see the pattern O, this open circle. And we have that, so there's some domain knowledge here. The open circle, or the small lowercase letter O, is used to represent a week where a clinical trial participant was supposed to come back to the clinic to get a check-in, but they did not. So this would be very important for us to know based on like adherence to the protocol. We would want to find out who's missing the visits. And then I'm going to leave an exercise right here for you all to work on. And so go ahead and work on this exercise, and that will be all for this video. So see you next time.